Hey everybody, so today we are going to continue with limits, and we're really going to focus on problems where we're taking the limit at a point that's not in the domain. All right, so pause the video and do this do now. Whenever you see a problem that looks like this with that like greenish box, I actually took it directly from your textbook. I have an online version of it and I just like snipped it. All right, which limit does not exist? So this is the limit as x approaches -1 from the right. Right and left limits always exist, so it's definitely not that one. So -2 from the left, it's not that one. Wait, they do exist, they're not the answer. Let's see. The limit as x approaches 2. So as x approaches 2 from the left, you get 4. From the right, you get 4, so that one works. So it must be -1. -1 from the left is -1. -1 from the right is a +1. So that's why it's a D. Okay. So this is based on what we did yesterday. So pause it and do these two. All right. So we have, if I rewrite this as the limit as x approaches 5, 2 times x minus 5 over x minus 5. Oops, the x minus 5's cancel it out, and we're just left with 2. And then this one, same idea, similar idea. We try to factor it, but what happens if we try to factor it? Do those cancel? They don't. Why is that not an issue? Before you start trying to cancel stuff, just plug in. This one I like to give as a trick because when you plug in, you get -36 plus 36 over 24. 12 minus -12 is 24. You end up getting 0 over 24, which is just 0. So be careful. Don't always assume that you need to cancel anything. Always plug in before you do anything. The one on the top, it's pretty quickly you can see, okay, 5 minus 5 is 0. 10 minus 10 is 0. I do have to cancel. But always check that first. Don't just automatically start trying to factor and cancel. Okay, so if you remember what we did yesterday, whenever you have a square root like this, you need to multiply by the conjugate. So on the top, root 7 minus root 7 is 0. So you do get 0 over 0. So we're going to multiply the top and bottom by the conjugate. So root x plus root 7, root x plus root 7. So the top, root x times root x is x. Again, we're only dealing with positives, so we don't have to worry. And then leave the bottom factored. Don't multiply all that out. It will make your life more difficult because when we're doing these, things should cancel out. The x minus 7's cancel. So we have the limit as x approaches 7 of 1 over root x plus root 7. Now I can plug in and I get 1 over 2 root 7. All right. Pause the video and do the exact same thing. So we're going to multiply by the conjugate here. If you plug in 5 minus 5 is 0. Root 16 minus 4 is 0 over 0. So our conjugate for this one, x plus 11 plus 4, root x plus 11 plus 4. So we get the limit, x approaches 5. Leave the numerator as is. That's way too complicated to try to multiply out. Now let's see what we get on the bottom. Root x plus 11 times root x plus 11 is x plus 11 minus 4 times 4 is 16. That becomes our x minus 5. Our x minus 5's cancel. So then we just have to plug in. So we just have the limit as x approaches 5 of root x plus 11 plus 4. So that gives us root 16 plus 4, which is 8. All right, the difference quotient. So I don't know, sometimes Mrs. Blodgett teaches this in pre-calc. She may not have gotten to it because of COVID last year. But this is a function. You'll notice I've given you a lot of f of x plus h. This is the reason difference quotient's really important. All right, so the limit as h approaches 0 of f of x plus h minus f of x all over h. So this is we're gonna spend a lot of time with this formula. I'm not gonna tell you yet, but this does come back and it actually has a really significant meaning in calculus. So I have the limit as h approaches 0. So I'm gonna start with the f of x plus h. X squared, so that becomes x plus h squared, minus 3 times x plus h plus 4. So that's just this thing up here. That's the f of x plus h. But we have more to it now. Now I'm going to do minus f of x. Minus x squared minus 3x plus 4. And then all over h. All right, go through, simplify the top. And this is why I said it's really good if you can do this in your head. All right, so x plus h squared is x squared plus 2xh plus h squared minus 3x minus 3h plus 4. And then I'm subtracting, so then minus x squared plus 3x minus 4 all over h. Go through and find stuff. Stuff's going to cancel. My x squareds cancel, my 3x's cancel, and my 4's cancel. So we end up getting the limit as h approaches 0 of 2xh plus h squared minus 3h all over h. Now what can we do there? We still get 0 over 0. If you plug in, you get 0 over 0. But we can divide each of those terms by that h on the bottom. I can divide that out. So that's the limit as h approaches 0 of 2x plus h minus 3. Now I can plug the 0 in, and I'm left with 2x minus 3. So what's really common with these is we're going to be left with an expression. We're not going to be left with a number necessarily. It depends on the problem, but this one in particular, there is no, it's not an integer answer, it's just an expression. All right, same idea. I want you to take a minute and plug into the limit formula. So we have the limit, h approaches 0. So we have 5 over x plus h squared minus 5 over x squared all over h. So again, if you start trying to plug in, you do get 0 over 0. So think about what can we do? What's something we know how to do with fractions? When I have a fraction, I can make a common denominator. So that's what we're going to do. This left side, I'm going to put in an x squared. Whatever I do in the bottom, I do in the top. The right one, x plus h squared, x plus h squared. All right, so we get the limit, h approaches 0. So I get the whole stuff on the top is 5x squared minus 5 times x plus h squared all over x squared, x plus h squared, and then all that is all over h. Now, this always messes kids up. When you're dividing a fraction by a number, say, I'm going to go look up on the top. If I have 1/3 divided by 2, that's a 1/6. When you're dividing a fraction by a number, you can just move that into the denominator. Or if you think about it this way, 1/3, let me turn my pen off. 1/3 divided by 2, that's really 2 over 1. When you divide by a number, you multiply by the reciprocal. So 1/3 times 1/2 is 1/6. The reason I'm telling you this is because this h can just go in the denominator. So this is the limit as h approaches 0. So this denominator is h x squared x plus h squared. Now go through and simplify that numerator. So we have 5x squared minus 5x squared minus 10xh minus 5h squared. Again, stuff should cancel if we did it right. So those two cancel. So we're left with the limit as h approaches 0, negative 10xh minus 5h squared all over hx squared x plus h squared. We still get 0 over 0. Again, just like in that last one, now we're going to divide out the h. So this h cancels out with this h and the squared. So we get the limit as h approaches 0, negative 10x plus 5h all over x squared, x plus h squared. And now we can plug in. When we plug in 0 in for h, this goes away. We're left with negative 10x. This goes away. So we have x squared and x squared, which is x to the 4th. And then we can make that negative 10 over x to the 3rd if we want. That's good. Done. I know, it's a lot of algebra, and that's why algebra is the hard part. Algebra is the hard part. It's not plugging in 0. It's going through and doing all that crazy algebra. Okay, the average rate of change formula. So if you look at this, this should look semi-familiar. What does this remind you of? Hopefully, it reminds you of slope, right? Change in y over change in x. These are y values. These are x values. So if f of x is 4x minus 3, what would f of c equal? Well, c in this case is 2. So f of 2 is 8 minus 3, which is 5. So we're going to do this one, the limit as x approaches c. In this case, c is 2. F of x is 4x minus 3 minus, what did we get for f of 2? 5 over x minus 2. So x's stay in the problem, and then the c is, in this case, is our 2. Simplify this. We get 4x minus 8 all over x minus 2. If we try to plug in, we get 0 over 0. This is back to the ones we were doing earlier. If I factor the top, I get 4 times x minus 2. Those x minus 2's cancel. So it's just the limit as x approaches to a 4, which is 4. And that's it. Now, think about this. What was this function that we just had? 4x minus 3? What is that? It's a line. What's the slope of a line? It's the number in front of x. Oh, hey. All that work, we could have just looked at it. Oh, it's a line. My slope's going to be 4, since average rate of change is just slope. Okay, pause the video. Try this one on your own. Same idea. So these are easier in my opinion. So we got the limit. X approaches 1. Remember, we rewrite f of x. 2x squared minus 6 minus, I plug in 1. F of 1 is negative 4. This becomes plus 4 over x minus 1. Let's simplify that. 2x squared minus 2. Try to plug in, you get 0 over 0. We're going to factor the top. So if I factor the top, I get 2x squared minus 1. So that's 2x plus 1, x minus 1, all over x minus 1. So my x minus 1's cancel. So I'm left with the limit as x approaches 1 of 2x plus 1. 2 times 2 is 4. All right, we're going to skip those. All right, that was the lesson. I know that was a lot harder. We're going to spend some time. Our next lesson, we're basically just going to be practicing this stuff because it's, again, the algebra is what makes this difficult. Have a fabulous day, guys.